What causes condensation in a real gas? Well, in an ideal gas, the particles don't interact. There's no attraction or repulsion energy between them. In fact, if you plotted their interaction energy versus distance, it would be very boring. There's no interaction energy regardless of the distance between the ideal gas particles. For real gas particles, there is an interaction energy. And as those particles get closer, that interaction energy becomes significant. When we plot it, it looks something like this. For very large distances, ideal gases and real gases have the same kind of interaction energy. Large distances, the interaction between the particles isn't very important. As the particles get closer, that interaction energy is more important. And you'll see the plot goes to a stabilization energy as the particles get closer. As the particles get very close, then that interaction energy becomes unfavorable. That is, there's an actual repulsion. You can't push the particles on top of each other. They have a significant volume, and they'll resist being pushed on top of each other. So there is a happy medium where you'll have a maximum attraction energy when the particles approach each other. And this attraction energy, if that is higher than the kinetic energy of the particles, then the particles can actually associate. That is, for low attraction energies, the kinetic energy is larger than the attraction energy, and the kinetic energy of the particles overwhelms the attraction energy. But as the kinetic energy goes down, and how do I lower kinetic energy? Lower the temperature. As I lower the kinetic energy, then the attraction energy becomes a more important factor, and the particles associate. That's the nature of condensation. So lowering kinetic energy to where the attraction energy is